So the next topic is single phase fully control rectifier with RO load. So on what topic we are seeing control rectifier converting AC to DC. Okay, so we are seeing in terms single phase. Okay, and that is also for R load we have already discussed. And now we are going to look for RL load. There will be an inductance. So you know the property of inductor there. What it will do? It will store some current. So what if the inductor is placed in the load? Okay. So how many for a fully controlled rectifier? How many thyristor will be there? Four thyristor. Thyristor has how many terminals are there in the ACR or thyristor?
Three terminals.
That is anode, cathode, and gate. When does the thyristor will turn on?
And the gate.
In the supply voltage along with the
Gate.
what is that gate? Gate signal or firing angle. It should be said as firing angle alpha. In the triggering pulse, firing angle is given to this gate terminal. It will start to trigger and it will start to turn on. Okay. So this is we will be naming it as thyristor number 1 T1 and this is thyristor number 2 that is T2 and this is thyristor number 3 and this is thyristor number 4. Okay, what supply we are giving?
AC supply.
AC supply. So terminals are phase and neutral. Okay, the phase is given to the first terminal that is to the T1, T4 and the neutral is given to the next that is T3 and T2. Okay, so now before what load we are seeing? We are seeing for RL load. So before we have seen R load, right? Along with that circuit, is we are need to add a inductor. That is now the load is said to be RL load. Clear? That is all about the circuit diagram. Now, after describing the circuit diagram, what is the purpose of the inductor? I have already yesterday I told you not actually far about it. What it is? What it will do?
It will store some current.
For why we are going for this inductor? Why can't we use the R and not alone?
Reduce the noise by the
That is to reduce
ripple.
ripples. Correct. Okay. So to reduce the ripples, while we are converting this AC to DC, there is some ripples in the flow of current. So in order to reduce the ripples, we are adding an inductor with the load side. Okay. So that what happens? The current will be only in the positive half circle. Okay. That is also less ripples, comparatively less than the R load. Now, for describing the principle of operation, first, during the positive half cycle, the thyristor T1 how it will be, thyristor T2 how it will be, and thyristor T3, T4. What about thyristor T3 and T4? You want to tell me now? Which thyristor will be in the turn on condition during positive half cycle?
T1.
RL. Okay. So four thyristors are there. Whenever I am giving it during positive half cycle, that is from the at omega t is equal to when it will turn on firing angle alpha. So at omega t equal to alpha during positive half cycle. Which thyristor will be in the turn on condition? Thyristor 1. Okay. So this thyristor is T1, right? So this will be in the on state. So the flow of current will be like this, right? So after that, which thyristor will be in the on condition? After that, after thyristor 1, it will flow through the RL load. The current will flow through the RL load. Next, will the thyristor T3 will be in the on state or in the off state?
Off state.
We have not given any figure. Number 2 is T3 and T4 and also it is in the reverse condition. So it will be in the off state. So we can just leave it blank. Okay, T3 off. No need to join that line, which means the switch is in the off state condition. If we have joined this line, means the switch is in the on state condition. Clear? So a single line will represent the simple operation. Okay, so be clear about it. If the line is clear, the T1 and T2, these two dots are joined means the switch is in the on state condition. If these two dots are separated by a line, there won't be any line means it is in the off state condition. So after on load, the current flow how it will be? It will flow through the
T2.
RL, it will flow through the T2. Okay, so the T2, what T2? T2 will be the on state condition. So we have to join these two lines. It means T2 is in on state condition. So the current will flow like this. Okay. This is the first positive half cycle principle of operation. During that time, what about T4? T4 will be in the off state condition. Okay. So how is the current flow? Whenever the omega t is alpha, the current flows from phase to thyristor 1. From thyristor T1 to RL load. Then to T2. Next to neutral, since the circuit is now closed. So now what happens? Now AC will be converting into DC. We will be drawing the waveform products. Okay. After drawing the circuit diagram, we have to see the principle of operation for the negative half cycle also. Okay. So negative half cycle. When does it will happen? Positive half cycle means omega t is alpha means at negative half cycle when does it will happen? Omega t is equal to? No. What is that? 5 plus alpha. That is positive half cycle over 5. Okay. Along with that 5 angle alpha. So omega t will become 5 plus alpha. So during negative half cycle. Have you drawn this diagram? The first diagram. Okay. Now I am showing this diagram for negative half cycle. But omega t is 5 plus alpha. What about the switch T1?
Off state.
During negative half cycle means the current will flow from the neutral. Okay. So now, which switch will be in the on state? T3 will be in the on state condition. So I can join that line. So I can't join the T1 thyristor since it is in the off state condition. The firing angle 5 plus alpha is given to T3. Next, the current will flow through
RL.
So in this direction it will move. Later it will flow through the RL load. After reaching to the RL load, the current will flow through. Here is the thyristor called T2. Will it on or off?
Off.
So there won't be any connection to T2. T2 is in the offset condition. There is no firing angle in it. 5 plus alpha is not given to this. So where the current then flows through T4. So this should be joined, which means T4 is in the on state condition and the current now flows through who?
Neutral.
The current will now flows through phase. Okay, it starts from neutral and ends with phase. So you can write the flow of current as from neutral to T3. Alright. So next from T3 to RL load and from RL to T4 then to phase. So this is the negative half cycle as similar to that of the resistive load. How we have seen so far for resistor load, the same case we are seeing for RL load. Hereafter there is going to be some changes after drawing the response of the output graph. Okay, so did you copy this to the first when omega t is alpha? Did you copy this diagram? So you can understand it, you can copy it itself. So now listen to the output response graph. Our input is sinusoidal AC, that is Vm sin omega t. Okay. Okay, let's copy. Okay. So now for RL load, due to inductive nature, due to storage of energy, what happens? The negative, it is going to be in reverse direction also. Okay. So here alpha, and this side is pi, and here it is pi plus alpha. Again this will be 2 pi, and this will become 2 pi plus alpha, and here it is 3 pi. Clear? So I am giving alpha trigonometers, that is from T1 and T2. That is only for the positive half cycle. Positive half cycle is alpha and 2 pi plus alpha here. And for pi random alpha is being given to T3 and T4. It is trigger when it trigger during the negative half cycle. That is during the pi plus alpha, next to 3 pi plus alpha, it goes up. Okay. So during that time, however, output voltage will be. Okay. Initially, our output voltage will start from where? From the alpha. Okay. So from alpha it is starting, and it is going to be a saturation region at some point. After some point, what happens? It will decreases. At the point pi, it will reach 0. Okay. This is similar to R1. And here, who is there in their circuit? Inductive nature is there. Inductance will do some storage. Okay. So after reaching to 0, what happens? Inductive will release its stored energy, because there is no supply voltage inside there. So what does it will do? It will release that stored energy. So due to that, there will be a flow of voltage in the reverse bias condition. So under that BGM, what will happen? The output load voltage will go to the negative side. Okay. So after that, next two is given. Then again pi plus alpha is given. There is a continuous conduction mode is there. Continuously the conduction is starting by the triggering by this switch. T3 and T4 is in the on state condition. Again the voltage will start to rise. Can you able to follow me? So again the voltage will start to rise like this. Okay. So again it will reach to the same. This process will be repeated. So again it will reach to 0 at the 2 pi. Okay. After reaching 0 at the 2 pi, what will happen? It will go to the negative. Okay. So again, if I plus 2 pi plus alpha is given, this positive half cycle is going to happen. So again, it will rise and it will reach us at 0 at infinite. Okay. So if the cycle is continuous, what about the initial state then? Will it be 0 or will it be in the reverse condition? Reverse condition. So it will be like this. But what if the previous condition is? Okay, you should not draw this as 0. Okay, that is why I am mentioning this. If this process is continuous, means previously it's also the stored energy will initially release because it is that this process is continuous conduction mode. Okay, so are you clear with that? This is the output voltage response for the RL load. Okay. As like as in the we have discussed half-wave control rectifier, they are also the same. The one thing different is there will be any conduction in the negative half cycle. Same graph da half-wave control rectifier is there, theta da below, but still the negative half cycle will remain 0. There won't be any thyristor to conduct in the negative half cycle. Fully half control rectifier continuous conduction is clear with it. And now, how the flow of current will be. So, what is happening? During reverse condition also there is some flow of voltage, which means there is some flow of current. So, the current won't go to 0 or it won't go to negative. So, the current is going to be, since there is a minimal voltage, the current will be there. Okay. So, since there is a supply voltage, current will be there. Since there is a minimal voltage, current will flow. Likewise, since there is a supply voltage during the negative half cycle, the current will flow. The same. Since there is a negative voltage, minimal voltage, current will flow. So the current waveform is continuous. This is what we need. Okay. The direct current should be like this. Okay. So it should not go to 0 or it should not go to negative side. So that impulse can be much reduced than compared to the R code. That's it. Okay. So after drawing this, you have to here itself there is two mode of operation is there. Okay. What if alpha is? If I am predicting this alpha over here, right? So if this is pi means what is this one? The half of it.
5 by 2.
Pi by
2.
which means 90 degree, right? So we are going to separate it in two conditions. That is 90 degree. What if alpha is less than 90 degree? Likewise, what if alpha is greater than 90 degree? Okay, we need to separate. We have to study the two mode of operation also in the RL. Okay, initially we have seen for alpha that is less than. Can you able to follow me? Initially நம்ம பார்க்கிறது எல்லாமே alpha என்னதான் less than 90 degree தான். இப்போ நான் இன்னொரு மோட் நம்ம பார்க்க போறோம். Okay, that is greater than 90 degree for specifically for fully controlled rectifier with RL. Okay, so draw this diagram. Let's see the function is working everything with respect to what omega t. Okay, and up to this we have seen, right? So generally we have seen alpha less than 30 degree, 90 degree. Okay, we have taken, for example, we have taken omega t that is equal to alpha. At what range can I fix for it? If this is 90, second shall fix it 30. So I have taken alpha as 30 degree, right? That is less than 90 degree, approximately 40 degree or 50 degree. Okay, so anyhow it is less than 90 degree. So generally we have seen a waveform that is what alpha is less than 90 degree, that becomes under rectification mode. Okay, so next, what if the alpha is greater than 90 degree? Okay, what does the detector will do? It will release up the stored current will be released from it, so it is in the continuous conduction state. So, and one thing we have to know that when does the what about the thyristor T1 and T2? What about the current flowing through it? It is current through thyristor 1 and current through thyristor 2. When does the thyristor listen to conduction of thyristor T1 and T2? When it is conducting from alpha to 5 plus alpha, right? So till then there is no conduction. So T1 will conduct only when the alpha to 5 plus alpha. Okay. Next, when does it will conduct from 2 pi plus alpha to 3 pi plus alpha it will conduct, right? So this is 2 pi plus alpha and this may be 3 pi plus alpha. Clear? And next, what about the current that flows through the T3 and T4? It is in the positive half cycle. What about the current of T3 and T4? It will conduct from, so it will remain 0 till pi plus alpha. So it will conduct from 5 plus alpha to 2 plus. That is the reason the current is in the continuous condition. So it is a single cycle, right? So if you merge these two, I have separated it in terms of T1 and T2 and T3 and T4. So it is a continuous condition. If you measure, the current is in the continuous. This is called alpha less than 30 degree, that is rectification. What if alpha is greater than 90 degree? And the name was called inversion mode. Okay, so let's see the first. Our input is sinusoidal nature. V in, that is Vm sin omega t. So this is what everything happens with respect to omega t, and this is for alpha, trigger impulse for T1, T2, and the next is for alpha, trigger impulse of T3 and T4, and the next we will be drawing for output voltage V0 with respect to omega t, and the next we will be drawing for output current with respect to omega t, and similarly omega t for the current at thyristor 1 and current at thyristor 2, IT1, IT2. Okay, so the last we will be drawing for with respect to omega t, we will be drawing for current to thyristor 3 and current to thyristor 4. Clear? And now alpha should be greater than 90 degree, inversion mode condition. So this is 90 degree, that is pi by 2. So this is 0 and here it is 180 degree, and this is 2 pi and this is 3 pi. Okay, I will be taking greater than 90 degree, so I am taking this side. Okay, so this is 5 again during negative half cycle. This is 2 pi and here 2 pi plus alpha 3 pi. Okay, so this is alpha now and this is pi plus alpha. Alright, and this is 2 pi plus alpha. Clear? So when does the conduction start from T1? During alpha. Pi equals is given greater than 90 degree. And here it is given at 5 plus, sorry, this is for T negative, positive half cycle. 2 pi plus alpha. And for negative half cycle, it will be given to 5 plus alpha. Clear? And what is the conduction output voltage? Okay, output voltage will start from alpha. Alpha is greater than 90 degree. So 90 degree means the inverse of it, right? Inverse means the voltage will be in the negative direction. The conduction starts from the negative side. Okay, this is how we will be starting. Conduction starts from the negative side. Okay, because this the alpha is greater than 90 degree. Okay, less than 90 degree means it is positive. Greater than 90 degree we see. So the conduction of the voltage starts from the negative side. So after that, it will reach us to 0 at 5. So what about till it reaches to the next negative half cycle? After that, 5 plus alpha is given. So the voltage will rise again. Again, it will reach us up to 5 over here. Okay, so it will reach us until negative at 2 pi plus alpha is given now. Can you able to follow me? Likewise, again it is 0 and it will follow. This will continue. And what about this session will be? It will be also the same continuous. This is how the voltage output voltage waveform and alpha is greater than 90 degree. That is during the inversion. Okay. So the next is current through T1 and T2. When will be the conductions from alpha to 5 plus alpha to 5 plus alpha. Okay. So when will the T1 and T2 conduct? Same here, alpha to 5 plus alpha. Till then the current will be 0. So alpha to 5 plus alpha. Again
2 pi plus alpha to
2 pi plus alpha to
3 pi plus
3 pi plus alpha. What about the current to the x3, T3 and T4?
5 plus alpha to
5 plus alpha to
2 pi plus alpha.
2 pi plus alpha. Clear? That is all about inversion mode. That is alpha is greater than 90. Okay. So today the derivation small derivation, it is not bigger. So now what will be calculating? Average load voltage, or you can say that average DC voltage. Okay, so that is V DC. So for fully controlled rectifier, for what cycle we are considering? 0 to pi, right? So 1 by pi integral. Conduction starts from
Vm sin omega
conduction starts from
alpha
alpha
to 5
to 5 plus alpha. The next trigger equals that it is giving, that is the ring. So who is will be there? Input voltage Vm.
sin omega t to
Here. So next 1 by pi. If I integrate, I can take the Vm outside, right? Vm is constant. So it will become Vm by pi. If I integrate sin omega t, it is minus cos omega t limit varies from pi plus alpha to alpha to pi plus alpha. So what about reducing then? Vm by pi. If I substitute the limit, it will become minus of cos of pi plus alpha minus of upper limit minus lower limit minus minus of
cos alpha.
cos alpha. Okay. So the next, what will be doing? VDC is equal to
Vm
Vm by pi. Shall I write it this first? Minus with minus it will become plus. So I am writing cos alpha plus minus cos of pi plus alpha to the second. What cos pi plus theta? Formula. Trigonometric formula. Cos pi plus theta is equal to cos pi is what? Pi is 180 degree. 180 degree plus theta means
1.
the next is second half secant, right? So it will be minus cos theta. If cos pi up to 180 degree is positive means 180 plus theta is what? Negative. So minus cos theta. Okay. So cos pi plus theta is minus cos theta. So what happened? Vm by pi cos alpha. So minus of, instead of cos pi plus alpha I can substitute
Cos minus cos
minus cos
theta.
theta is what here? Alpha. So it will become Vm by pi
2 cos alpha.
2 cos alpha. So I am writing the 2 over the front, cos alpha to the next. That is 2 Vm cos alpha. Now I am writing the bracket. Here this 2 Vm by pi cos alpha is the average DC voltage or average load voltage. And what about IDC then? VDC, right?